Welcome back to Tech Unplugged, everybody. Today we're doing another deep dive in our database series, and this time it's all about MongoDB.
Sounds good.
Yeah. Based on what you've seen and all the stuff that our listeners have sent in, what can you tell me about MongoDB? I mean, where do we even start?
Well, like you said, we got a ton of great resources this time around, covering everything from the basics to more, complex stuff like how to make it secure, performance tuning, even comparing it to SQL databases.
Okay, yeah.
But I think the first thing we got to address is that MongoDB is a NoSQL database.
Okay, so immediately that tells us it's different from the kind of traditional SQL databases that a lot of folks might be used to.
Exactly. And the reason for that is, at its core, MongoDB is designed to work with data that isn't, like, perfectly structured. Like think about data that doesn't fit neatly into rows and columns.
So we're talking about things like unstructured data, semi-structured data, even what they call polymorphic data, right? Where the structure can vary within the same data set.
Right. And that's actually a perfect segue into how MongoDB actually stores this data. Instead of those rigid tables, MongoDB uses these like JSON-like documents, which is super flexible.
No, hold on. It's not just plain old JSON, is it? I seem to remember something about BSON.
You're right. It's not just plain JSON. MongoDB uses BSON, which is a binary form of JSON. Think of it like JSON, but specifically designed to be more efficient for a database.
Makes sense.
But what's really neat about BSON is that it doesn't just stop at the usual JSON types like strings and numbers. It goes further by adding support for things like different sizes of integers, dates, and even a decimal type, specifically for like super precise calculations.
So basically, MongoDB can store a wider variety of data without needing to, like, convert it first.
Yeah, exactly. And that's a huge advantage both for developers and for performance.
Okay, so we know that MongoDB stores data differently and that it can handle various data types, but why is that a big deal?
Well, think about the kinds of applications that are being built today.
Yeah.
Social media, e-commerce, IoT devices, all generating massive amounts of data, and often it's not very structured data.
Right, and it's constantly changing, too.
Exactly. So with traditional SQL databases, you have to define a very strict schema up front, and that can become a real bottleneck when your data is evolving rapidly.
So MongoDB kind of sidesteps that by using these flexible documents. But how else does it deal with all of that data and the demand for speed? What were some of the key themes you saw emphasized in the materials?
I'd say the three words that kept popping up were scalability, performance, and flexibility. I mean, MongoDB is built from the ground up to handle those huge data sets and high volumes of traffic. It's really about being able to adapt and grow as your needs change. And all those things are super crucial in today's world, like with big data and needing results fast.
It definitely sounds like MongoDB is built for the modern data landscape. Now, I know MongoDB is part of the NoSQL family, but what are some other examples of NoSQL databases out there, just to kind of give listeners a better idea of the broader ecosystem?
Sure. Besides MongoDB, you have a bunch of other popular NoSQL databases like Cassandra, Redis, CouchDB, and Neo4j. Each one has its own strengths, but they all share this common idea of moving away from the traditional relational model.
So we've established that MongoDB is a NoSQL database. It's built for flexibility and scale, and it's part of this broader ecosystem. Let's get a little more specific now. What are the basic building blocks of MongoDB? Like, if we're going to understand how it works, what are the core things we need to know?
Well, like any database, you have to have a way to organize your data. In MongoDB, the basic unit of organization is a collection.
So kind of like a table in a SQL database.
Yeah, you could think of it that way, but the big difference is you don't have to predefine a schema for a collection. You just start adding data, and MongoDB figures it out.
That sounds a lot less restrictive than SQL. So we have these collections, but what goes inside a collection? How's the actual data structured?
Right, so inside a collection you have documents, and these documents are what make MongoDB so flexible. They're essentially JSON-like objects with key value pairs.
Okay, so key value pairs, that's pretty straightforward.
But the cool part is that each document within a collection can have different fields and even different data types. You're not locked into a rigid structure. It's like you can just keep adding information as needed.
So for developers, that means less upfront planning and more, I guess you could say, agility to adapt to changes in the data.
Precisely. It makes development much faster and less headache-inducing.
Now, let's say we're setting up MongoDB. We have our collections, our documents. What about the thing that's actually running, the actual instance of MongoDB? What's that called?
Yeah, that's just referred to as a MongoDB instance. It's the running process that's managing all your data, storing it in memory and on disk, and it communicates with any applications that need to use the database.
Okay, simple enough. Now, I know from the research that MongoDB is all about reliability and scalability. How does it actually achieve those things? I mean, what are the architectural patterns that make it so robust?
Right. So two key concepts here are replica sets and sharded clusters. They're kind of like the foundation of MongoDB's ability to handle a lot of data and traffic without like falling apart.
Let's break those down one by one. First up, replica sets. What are they all about?
So with replica sets, you're basically creating multiple copies of your database, each running on a separate server. It's like having backups, but they're live and active.
So if one server goes down, the others can keep things running.
Exactly. There's always a primary node that handles all the writes, and then you have secondary nodes that are constantly syncing up with the primary. And the best part is these secondaries can handle read requests too.
Oh, so that helps spread the load and keeps things running smoothly, even under pressure.
Exactly. Now, I also remember seeing something about write concern. I think it's about making sure that data is properly saved.
You're right. Write concern lets you control how MongoDB confirms that a write operation was successful.
Oh, okay. So it's not just like fire and forget.
Right.
There's a way to make sure things are really saved.
Yeah. The default setting ensures that the data is written to a majority of those replica set members before it's considered done. It's a good balance of speed and safety.
That makes a lot of sense. Okay, so we've got replica sets for redundancy and availability, but what about when you have just like an astronomical amount of data or tons and tons of users hitting your application? That's where sharding comes in, right?
Exactly. Sharding is how MongoDB handles truly massive scale.
And it's all about breaking things down into smaller, more manageable pieces. It's kind of like dividing a really, really long book into multiple chapters.
It's more like dividing a huge library into different sections. So you have these smaller, self-contained units that can be spread across many servers.
Yeah, exactly. Each of those chunks is called a shard. And then you have these query routers, or Mongo's processes, that act as the traffic cops, directing incoming queries to the right shard.
Right. So the Mongo's is figuring out, okay, this data lives over on that shard over there. But how does MongoDB decide which data goes on which shard in the first place?
That's determined by the shard key, which is a field you choose when you set up your sharded cluster. And choosing the right shard key is super important because it affects how evenly your data is distributed and how efficiently your queries can be handled.
It sounds like there are a lot of moving parts in a sharded cluster.
There are. There's also something called a balancer process that constantly monitors how data is distributed across the shards. If one shard starts getting overloaded, the balancer will automatically move some data to a less busy shard. It's pretty cool, actually.
Like a self-balancing system to keep everything running smoothly.
Exactly. Now, moving away from the high-level architecture, I remember the research mentioning something about WireTiger. It seemed to be pretty important for how MongoDB actually stores data.
Right. WireTiger is the storage engine that MongoDB uses, and it's been the default since version 3.2.
Storage engine. So like the part of the software that handles the nuts and bolts of how data is written to disk.
Yeah, exactly. It's responsible for things like data compression, caching, and concurrency control.
So like making sure that lots of operations can happen at the same time without like messing things up.
Exactly. WiredTiger is designed for high performance, and it uses some clever techniques to handle concurrent read and write operations really efficiently. It's like a well-oiled machine working behind the scenes to make sure everything runs smoothly.
Okay, so we've covered the building blocks and how MongoDB is structured for reliability and scale. But let's talk about actually using it.
Yeah.
How do you go about creating databases and collections in MongoDB?
Well, this is one of the areas where MongoDB really shines in terms of ease of use. Creating databases is often implicit.
Implicit, you mean you don't have to explicitly tell it to create a database?
Exactly. The database is created the first time you try to store data in it. Of course, if you want to be more explicit, you can use the use command.
Ah, okay. And what about collections? Is it the same idea?
Pretty much. Collections are also created implicitly when you first insert a document into them. You don't have to define their structure up front.
That's pretty cool. It makes things super simple to get started. So let's say we have our database and collection set up. How do we get data into MongoDB? Like, how do you insert those documents?
For that, MongoDB has these methods called insertOne and insertMany.
So insertOne would be for adding like a single document at a time.
Exactly. And insertMany is for adding, well, many documents in a single batch.
Okay, that makes sense. It's kind of like the difference between sending a single letter and sending a bulk mailing.
Perfect analogy. You just provide the document or an array of documents, and MongoDB handles the rest.
Okay, so we know how to add data, but once it's in there, how do we get it back out? How do you query MongoDB to find the specific documents you need?
This is where the find method comes into play. It's the workhorse of MongoDB queries. You can provide a query document to specify the criteria you're looking for, and MongoDB will return the matching documents.
Okay, so if you want to find, say, all customers who live in a certain city, you would create a query document that specifies that city.
Exactly. Now, there are a few variations of the find method. If you're just looking for a single document, you can use findOne.
And that'll just give you the first one it finds.
Exactly. And for larger result sets, the regular find method returns a cursor. It's basically a pointer to the results, so you can iterate through them as needed.
Okay, so you can go through them one by one, or maybe process them in batches.
Right. Now, I remember one helpful tip from the research. If you're working in the MongoDB shell, appending .pretty to your find command can make the output much more readable.
Oh yeah, I've seen that. It really helps when you're dealing with those nested documents.
Mm-hmm.
So we know how to find data. What about changing existing data? How do you update documents in MongoDB?
MongoDB provides methods like updateOne and updateMany for updating documents, and they use these special update operators.
Update operators.
Yeah, things like set to change the value of a field or push to add an element to an array within a document.
So they're like little commands that tell MongoDB what kind of modification to make.
Exactly. And then there's replace one, which, as the name suggests, completely replaces an existing document with a new one.
Okay, so you have a lot of control over how you modify your data. What about deleting documents? That's got to be important too.
Absolutely. For deleting, you have deleteOne and deleteMany. Again, very descriptive names.
So deleteOne to remove a single document that matches your criteria, and deleteMany to remove multiple documents. Makes sense.
You just provide a query document to specify which documents you want to delete.
That seems pretty straightforward. But what about when you need to do more complex data manipulations? Like, what if you want to aggregate data, calculate statistics, or just reshape your documents?
For those kinds of tasks, MongoDB provides this powerful tool called the aggregation framework.
It sounds fancy. What makes it so powerful?
Well, with the aggregation framework, you can create these pipelines of stages, and each stage performs a specific operation on the documents.
So it's like an assembly line for data. Each station does a different task.
Exactly. You can use stages like match to filter documents, group to group documents, and do calculations like sums or averages, and project to change the structure of the documents by including or excluding certain fields.
Oh, I see. So you can chain these stages together to do some pretty sophisticated data transformations right within the database itself.
Exactly. It's a really versatile tool. Okay, now, as databases grow, performance often becomes a big concern. How does MongoDB handle that? I know the materials mention indexing, but I don't really get how it works.
Indexes are crucial for keeping queries fast, especially when you're dealing with large data sets. Basically, an index is like a lookup table that helps MongoDB quickly find the documents that match your query.
So instead of having to scan through every single document in a collection, MongoDB can use the index to quickly jump to the relevant ones.
Exactly. It's like having a sorted index at the back of a book. You can quickly find the page you're looking for without having to flip through every single one.
That's a great analogy. So what kinds of indexes does MongoDB support? I know there were a bunch of them mentioned.
Yeah, MongoDB has a whole bunch of different index types to suit different kinds of queries. You have single field indexes, compound indexes, which cover multiple fields, text indexes for doing full text search, geospatial indexes for location-based data, hashed indexes, wildcard indexes, and even TTL indexes, which can automatically expire documents after a certain amount of time.
Wow, that's a lot of options. How do you actually create an index in MongoDB?
It's pretty simple. You use the create index method and specify the field or fields you want to index and the type index you want to create.
So if you wanted to create, say, an index on a field called customer name, it would be something like create index and then customer name.
Yeah, something like that. You also specify whether it's an ascending or descending index. And for compound indexes, you just include multiple fields.
Okay, so indexes are clearly important for performance. But how do you know if your indexes are actually working? Like, how can you tell if MongoDB is actually using them?
That's where the explain method comes in handy. You can use it on any query, and it'll show you the execution plan, including whether an index was used and how many documents MongoDB had to look at.
Oh, so it gives you insights into how the query is actually being processed.
Exactly. It's like having X-ray vision into your queries.
Mm.
Okay, so we've covered a lot of ground. We know how to get data in and out, how to update and delete it, and how to keep things fast with indexes. But what about data consistency? How does MongoDB ensure that data stays accurate, especially when you have multiple operations happening at the same time?
This is a really crucial aspect of any database system, and it's one area where MongoDB has evolved significantly. Traditionally, NoSQL databases were known for their flexibility, but sometimes struggled with ensuring data consistency.
Right, and MongoDB used to be no exception.
Yeah,
But then they introduced multi-document transactions.
exactly. Transactions allow you to group together a series of operations and treat them as a single, indivisible unit. Either all of the operations succeed or none of them do. It's that classic all-or-nothing approach.
So it's like a safety net that prevents your data from ending up in a weird, inconsistent state.
Exactly. This means MongoDB can now handle those mission-critical applications where data integrity is absolutely paramount.
Oh, that's a big deal. I can see why that would be a game changer for a lot of use cases.
Mhm.
Now, we already talked about sharding as a way to scale horizontally, but what are some other strategies for scaling MongoDB?
Well, besides sharding, you can also scale vertically. This is where you simply upgrade the hardware of your existing server, giving it more processing power, more RAM, or faster storage.
So kind of like instead of getting more cars on the road, you just get a bigger, faster car.
Precisely. Now, vertical scaling has its limits. Eventually, you hit a point where you can't make a single machine any bigger or faster. That's why sharding is usually the way to go for truly massive scale.
Okay, makes sense. Now, security is obviously a huge concern with any database.
Mhm.
What are some of the essential security practices we need to know about when working with MongoDB?
The materials we reviewed really emphasize the importance of a layered security approach. You don't want to just rely on one thing. You need multiple layers of protection.
So like multiple locks on the door.
Exactly. The first layer is authentication. This is how you verify the identity of users and applications that are trying to connect to your database.
And the most common way to do that is with passwords.
Passwords are definitely common, but MongoDB supports more secure methods too, like Scram, which is a challenge response mechanism. There's also I.509, certificate authentication, and integration with LDAP, which is often used in enterprise environments.
So you have a lot of flexibility in terms of choosing the authentication method that's best for your needs.
Exactly. But authentication is only the first step. Once someone is authenticated, you need to control what they can actually do within the database. That's where authorization comes in.
Right, because just because you're allowed in the building doesn't mean you have access to every room.
Perfect analogy. MongoDB provides role-based access control, or RBAC, for this purpose. You define roles with specific permissions and then assign those roles to users or groups of users.
So you might have a role for read-only access, a role for administrators who can do everything, and so on.
Precisely. Now, one thing the materials really stressed was the importance of being careful with permissions.
Meaning you don't want to give users more access than they absolutely need.
Right. It's all about the principle of least privilege. Now, another key aspect of security is auditing.
Auditing, so like keeping track of who's doing what within the database.
Exactly. You can configure MongoDB to log various events like authentication attempts, administrative actions, and even data access patterns. This creates an audit trail that can be really valuable for security analysis and forensic investigations.
So if something suspicious happens, you can go back and see who was involved.
Precisely. It's also crucial to keep your MongoDB installation up to date with the latest security patches.
Oh yeah, patching is always important no matter what software you're using.
Absolutely. And don't forget about network security. Things like firewalls and network segmentation are really important for controlling access to your database. You want to make sure you're not leaving any doors wide open.
So it's a combination of securing the database itself and securing the network that it's running on.
Right. You need a holistic approach to security. Now, let's shift gears a little bit and talk about data modeling. Specifically, the trade-off between embedding data and referencing data.
Oh yeah, that came up a lot in the materials.
It's a fundamental decision you have to make when designing your database.
So what's the difference between embedding and referencing?
Embedding is when you store related pieces of data directly within the same document. For example, if you have a customer document, you might embed their address information as a nested object or array within that same document.
So everything is contained in one place.
Exactly. And this can make queries faster because you don't have to join multiple collections. But on the other hand, if the related data is very large or is frequently updated independently, referencing might be a better option.
So with referencing, you'd store the related data in a separate collection and just have a link, like an ID, in the main document that points to the related data.
Exactly. This approach can be more efficient for managing large evolving data sets and avoids unnecessary duplication of data.
Okay, so it's really a trade-off between query speed and data management efficiency.
Right. The best choice depends on the specific needs of your application. Now, one area I'm really interested in is how MongoDB is being used in the world of AI and LLMs. The sources mention that MongoDB is well suited for handling the kind of data that's often used in these applications.
It's actually pretty fascinating. MongoDB's flexible schema makes it really adaptable to the various data types you find in AI, like time series data, geospatial data, and even the embeddings generated by LLMs.
Right. And because MongoDB can store a wide range of data types, it can serve as a single source of truth for all the different kinds of data that an AI application might need.
So it's like the central hub for your AI data ecosystem.
Exactly. And the sources also highlighted that MongoDB is LLM agnostic, meaning it can work with any kind of large language model. That's really important in this rapidly evolving field.
It gives you a lot of flexibility and future-proofing. So MongoDB seems like a really solid choice for AI and LLM applications.
I definitely think so. Now, the final topic I wanted to touch on is the classic comparison between MongoDB and SQL databases. It's something that people often struggle with when choosing a database.
Right, it's like the age-old debate.
Exactly. And the truth is, there's no one-size-fits-all answer. It really depends on the specific needs of your project.
From the research, it seems like MongoDB really shines when you need agility and scalability. It's perfect for handling those massive data sets in those situations where the data structure is constantly changing.
Right. If you need to be able to move quickly and adapt to new requirements, MongoDB is a great choice.
On the other hand, SQL databases are known for their strong data consistency and their ability to handle complex relationships between data.
So if you have a well-defined data model and you need absolute guarantees about data integrity, SQL might be a better fit.
Okay, so it really comes down to what your priorities are.
Exactly. You have to weigh the pros and cons of each approach and choose the one that best aligns with your specific needs.
That makes a lot of sense.
Well, that was a deep dive.
Definitely deep.
We covered a lot of ground today, from the basics of MongoDB to some pretty advanced concepts.
We talked about how it's structured, how it scales, how to secure it, even how it fits into the world of AI.
We hope this deep dive into MongoDB has given our listeners a much better understanding of what it is, how it works, and why it's become such a popular choice for so many different types of applications.
Absolutely. And remember, the best way to truly understand MongoDB is to get your hands dirty and start using it.
Exactly. Experiment, explore, and see for yourself how this powerful database can bring your data to life. Thanks for joining us on this deep dive. We'll see you next time for another exciting exploration of the tech world.